let me explain what actually we are going to see. So I need to share the entire screen and going back to the slides. Oops, no, sorry. So as Angelo and Steven are going back to the car, let's recap a bit of the demo. So what we will have our Zenoh infrastructure, in this case, deployed through the pass, running on 3 different availability zones. So we have Tokyo, we have North Virginia, so US East Coast, and we have Frankfurt. And this is our Zenoh infrastructure running on the cloud. Then to this infrastructure, we attached a Zenoh router, which is running locally, in this case, in our office. And then we will have connected a car. Actually, we will have a laptop inside the car, which is the Steven laptop connected to a camera, but is then connected to a 5G phone. And this 5G phone is going to stream some video real time to the router that is in Frankfurt, as we can see from the pink line. Then this data is going from the router in Frankfurt back to our router in our office, back to an AI algorithm. This AI algorithm is going to run some classification and is going to publish some results. The result of this classification are streaming going back to the car. So let's imagine the car you can use them to avoid obstacles or to avoid in general, or to get any obstacles in general that are there. So it is offloading all this computation to an edge infrastructure. And in order to see that these are working live, I will also start a subscriber that is going to get the video out from the classification, so that we'll see in my laptop. And this is important to see that Zen is capable to send this data and to deal with this kind of real-time communication, because it's a way for, in the future, application offload the computation to the edge infrastructure. So let's imagine your car is going close to a crossroad and maybe doesn't need to actually perform all this computation inside the car. Maybe can offload this to an AI that is running nearby, that, as we said, is at access to context information and information from the other car, which means that is a way to actually first leverage context information and also reduce the cost of the car, because all of a sudden, if you don't need to put powerful computing inside the car will cost less, because the compute is not there, and the computing is something that is going to be, let's say, obsolete very quickly compared to the usual, let's say, time span of a car, and it's also usually quite expensive compared to other car parts. So the idea there is actually see how in the future, leveraging Zenoh, we can offload all this computation to the edge. And keep in mind that here we are using actual consumer deployment for the 5G. So the phone connector will be the phone from Angelo, which is connected to a customer network. So it's not kind of dedicated slice or dedicated network infrastructure for the V2X, which is something that usually OEM have when they have this kind of communication via a network operator to the cloud, or in general to edge infrastructure. But without further ado, let's check if the guys are already there. So let me actually stop sharing my screen very quickly, and I will share it back again. So we see Steven there. Hello, Steven.
Hello, everyone. Can you hear me?
Yes.
Great. So I'm here with Angelo. As Gabriele just explained, this part of the webinar will be somewhat more dynamic, so to say. So let me quickly go through the setup. Maybe while I do so, Gabriele, you can continue explaining if you're missing something.
Yeah. And by the way, just as now they can see the clear sky, show the rain outside, because the weather is completely crazy.
Yeah, I will do in just a second. So let me just change the camera over here. Well, now maybe this is better now. Can you guys see my background?
We see your laptop.
Great. So what we have in here, I don't know, Gabriele, if you already explained this part, but
yeah, I did, but we can show the different parts. So
great. Go ahead.
We have the phone. That's Angelo's phone connected to 5G.
The camera.
Yes.
The laptop. And that's it. And the car.
In the car, yes.
Yeah.
Let me just
Okay, so I think you can start sharing your screen then whenever you want, Gabriele, to show the feed.
Yes.
Let us know when we can get started. So let me put my.
Now you guys should be able to see my screen, and actually we are already seeing data coming from the car. So you see that in front of the car there is another car.
Shall we move?
Yeah.
Let's go. Do you see us moving?
Yes.
Great.
See how many cars there are there in the parking slot. So we can see it rained before. So now there's a bit of sun. As we can see, what is actually happening, as I described before, this data is coming out from Steven laptop, actually, so from the camera connected to Steven laptop, going through Angelo phone to send this data to the cloud in this case, coming back to our office, actually, being processed by the AI, and then the AI is going to add, as you say, is going to add a bit of information like the time that is used for inference, how many objects are detected, and of course the bounding boxes. So as they will approach the traffic light, we are going to see the bounding boxes for the traffic light, of course, some car detector there on the left and other signs. And of course, as again, the focus there is not the algorithm per se, is seeing that we can actually stream this data live directly from the car at real time. So you see the traffic light is red, so Angelo stopped.
Hopefully.
I did, don't worry. Yeah.
And we can see that there are a bunch of traffic light detected. Of course, then the algorithm is saying that those small signs are kind of
green.
Yeah, it's green, so we can go. Again, all of this is real time. I mean, the guys are in the car, as you can see from the stream, and they're actually, Angelo is actually driving while doing this, and we are connected to a consumer 5G network. So without any dedicated slice, anything. And this is just pure Zenoh latency at the end. And of course, the phone is connected, of course, through TLS, via Quick, as we said before, to the cloud infrastructure, and actually the same is happening in this case.
By the way, Gabriele, without an edge infrastructure, right?
Without an edge infrastructure, yes.
Yeah, because that's also quite important to gather. Yeah.
So indeed, so still there will be a bit of latency. I think in this case it will be few hundred of milliseconds, but that could be easily improved if we had Zenoh running on inside an edge infrastructure, if we had a dedicated slice for our car data. So we need to keep in mind always that, I said, this is a commercial deployment, a consumer deployment for the 5G. So no edge infrastructure, but still Zenoh is able to get this kind of performance. And we forget about the AI thinking that the fields is a train.
Yeah, well, that's systematic for some reason, right?
So do you want to explain a bit where we are? So the area, maybe?
Yeah, so this is the Plateau de Saclay, which actually is the innovation cluster, the biggest innovation cluster in the entire Europe. And here on our left, there is the Commissariat pour l'Énergie Atomique, which is a research center that does research pretty much on anything, starting from foundational physics up to anything you might imagine, like compilers, software operating system, blockchain, and so on and so forth. They did, for instance, the experiment that discovered the boson, that demonstrated the existence of the Higgs boson, was done by a team here at CEUA. We just left an accelerator, and over there, where is our office, roughly, right? There are all the top engineering schools and many other innovation centers and companies like Zetta Scale. And we're going to take the Highway 118 to then get back to the office. But we will do the Q&A from the car.
Yeah.
We'll, once we get out of the highway, maybe we'll do the Q&A, Gabriele.
Yeah, indeed. I mean, it's just to show that actually also going on an highway, so around 90 kilometers per hour, the communication.
We can go up to 110 over there, so yeah.
As you wish.
Preferably not, but
that's the speed limit.
That's the speed limit.
That's for demo sakes, guy, not because I like speed.
I mean, unfortunately, there is not that much car now on the road, but
we have some traffic lights over here.
We have some traffic light. Traffic light is always there.
On the highway will be better. We have a car behind us. Maybe I will let them overtake. I will ask them to overtake.
I can actually see the car.
So we will see a few cars in front of us. Yeah, that's good.
So we have a few cars. So we have a Dacia, as we can see.
Yeah, you have essentially no latency.
Yeah, no. That's exactly the performance of Zenoh. Showing no latency. I mean, nothing at the end is really optimized in this case because we are using everything from. We are going through the cloud. We could go through the edge if we had an edge infrastructure to further reduce latency. And actually, in the case, let's imagine you want to use something like this for digital witness use case. you do actually not need low latency. You just need to be able to get the data, to store it, to be able to reconstruct the scene of an accident in the case you need.
Yeah, but this could also be used to do, let's say, eventually advanced ADS, right?
Yes, advanced autonomous driving. Yes, autonomous system.
And it could be interesting because all of a sudden, if your car, because those servers are very expensive. So if you imagine some cheaper car that you only use in citadine environment, I mean, you could have the brain sitting on the edge.
Exactly. That's exactly what I explained before.
Yeah, we have demonstrated that already with robotics, right? We did the Dragon bot, and now we did the Dragon car or whatever. Almost. Yeah, here there are more cars, so it will be more fun here.
Yeah. You see some people overtaking you. Yeah.
Yes. They don't realize that we are into a demo. No, but I'm because I'm going too slow. They're right. Not even 70, and the speed limit here is 110. So we are speeding in 110.
So we can see all the cars, are being detected. So it's completely, that's perfect, actually.
Gabriele, should I get out or drive?
Yeah. I mean, we can get out. So, and then we can start getting Q&A.
Yeah. Okay, let's do that.
So actually, let me stop sharing my screen. Then we can get